Hey everyone, so in this video we are going to look at detecting collisions with particles. And it's actually somewhat different than checking other collisions because if you're using an object that has, say, a box collider, you can either use on trigger enter if one of the objects are set as a trigger, or you can use on collision enter if both objects are not set as trigger and they're just solid objects. But for a particle collision, you have to use a special routine that checks for particle collisions, and there's a few settings within the particle system itself. So I'm just going to create a very simple particle system and a simple 3D object because, as always, the actual visual appearance really doesn't matter. The graphics, I don't want to be a distraction. I want you to be able to focus on the code and the functionality. So, game object, 3D object, cube, and let's just move this forward a bit. And let's make this, let's scale this up for Y and Z. We can actually make this a little thinner for X. Let's just click on our camera. So yeah, there's the wall. Let's move it a little bit more like this. Okay, so now we need our particle system. So game object, effects, particle system. Again, we'll bring this forward. And now we'll rotate this towards the wall. Now we're just going to tweak this a little bit. We'll make these are really too big. We're going to make them smaller. The particles are too big. We also want to have more of them. So let's make the start size like 0.15. And we will have them not last as long. We'll have them last just, say, 2 seconds. And now we'll change the shape. So we'll concentrate this in. Also shrink the size of where we're starting. And now we'll increase the emission, so the rate. It's important to note that up here you have a max particle. So if you have a rate that's really, really high, once you've hit that max particle, it can't make any more until those have been destroyed. Now, this might be the kind of effect that you want, so keep that in mind, that you can make, say, like a ring or a burst effect by intentionally exceeding your max particles, but that's not what we're looking to do in this particular video. So first, we'll increase this. And the exact number doesn't matter as long as you don't exceed it. So, just rotate around so you can clearly see that it is passing through the object. And we'll just run this for a moment. So we know it's not running above it or below it or to the side of it. You can clearly see it's going through it. So now we want the collisions to occur. So unsurprisingly, with the particle system selected, there's a section called collision. You need to change this to world, and then watch what happens. Just like that, collisions are detected. Now there's certain things you'll have to do if you don't want these to bounce around like this. That we might get into at the end of the video. I just really want to focus on the functionality of detecting the collision and then doing something with it. So if you want, we can bring that lifetime down so it's not so dramatic. But like I said, that's really not the focus of this particular video. Okay, so here's the thing. Collisions are occurring, but you haven't finished what you need to do because the collisions are just applying physics, basically, at least a little bit of physics to the particles, okay? Messages need to be sent, though, or else the collisions are really not being tracked. So send collision messages. So once we've done that, what we can do is we can then have a script on this object that will detect the collisions. So right-click, create C#. We'll just call this part detect, so detecting particles. You can call it whatever you want, really doesn't matter. And then what we'll do is we'll click on our cube, put that script on it, and then open it up. If you're new to Unity, if you see this // that's just documentation. It's a remark. It doesn't actually get executed. It's simply saying that what happens in the start section happens when the object gets instantiated. In this case, the object that's going to be attached to the cube will be instantiated when the scene first runs. This says the update section happens once per frame. So outside of start, outside of update, what we're going to do, we're going to do on. See how there's that separate on particle collision? Because if you are familiar with Unity, you've probably seen on trigger, on collision. Okay, so there's on collision, enter, and on trigger, enter. Those do not work. Those work when you're looking at having solid objects collide with each other. If you're using particle systems, you absolutely have to use on particle collision. And the other stuff appears because I'm using Microsoft Visual Studio. Whenever you deal with collisions as well as like mouse clicks and things like that, always test. Because you don't want to go down the rabbit hole, have something really complex be written up and then have it not work. So I'm always recommending that when you first add a collision, always do debug log just to make sure it's working. So now, when a particle collides with the object, the debug log will say hi. There you go. So now that you've done that, now it's just a matter of actually doing something concerning gameplay. So again, in the script, which is attached to our cube object, so outside of start, outside of update, outside of on particle collision, but within the public class, we are going to write public int current HP. So the HP that your object currently has. Say it's 1,000. Whatever, doesn't matter. Now what we're going to do is in here, we are going to do HP, current HP minus equals 1. So in other words, whatever the current HP is equal to, minus 1 from it. So it's not setting it to 1, it's just subtracting 1. And now in the debug log, we'll put in current HP. There we go. It's important to note, though, and if you're looking at how relatively slowly that's moving, considering how many particles are hitting, only 1 particle per frame is being detected with the current process that we're using. So there's I'll probably do that in a separate video, but there's a way to collect every collision. Now, the reason why I'm saying this is because depending on the game, you might not care that every single collision. All you care is that there's at least 1 collision per frame. That's all you care about. So whether a weapon is, say, hitting someone full force or just clipping them, it does the same amount of damage. You could use this approach. But if it makes a difference, say it's like a flamethrower or something, and if they're being hit by a little, they take a little damage. If they're taking it full force, the whole cone is hitting them, then they're taking more damage. If you want that mechanism, like I said, I think we can handle that in a separate video. So with the AOE portion, completed, let's now look at the DOT portion, the damage over time. So basically what we need is we need a timer to be set to a certain amount of time, say 3 seconds, and that will get reset, refreshed back to 3 seconds every time there's a collision, because that's usually how a DOT works, is that every time the same DOT hits, the timer gets refreshed. Okay, and then what we want is we want that timer to reduce down to 0, and then once it reaches 0, there's no additional damage done. So how do we make that happen? So we come back to our script, and we're going to have to add a couple new variables. So public, let's do a float because it needs to use a decimal. So public float, and this will be burn time. And we'll set it to 0 because at the beginning there is no burn time, because it hasn't been set on fire yet. So let's also add public string on fire, and this will start as no. And this, why we need this, I'll explain in a minute. There's really no point until we get into a little bit further in coding, but it's a control we're going to need. So in the update section, what we're going to do, we're going to have burn time be reduced. So even if it's at 0, we don't care. We're going to have burn time be reduced. So burn time minus equals time dot delta time. For those of you who remember your math classes, delta is change in, so the difference. So this is just saying how much time has passed. We have to do this because since the update section is once per frame, if something is running at a slower frame rate, this happens less times per second. If it's a higher frame rate, then it happens more times per second. And again, there have actually been PC games where there was a glitch that the higher the frame rate, the more damage you took. So by doing delta time, it doesn't care about frame rate. It simply says how much time has passed, and we'll adjust that time accordingly. So what we now want to do is, if burn time, let's first create the coroutine that we need. So outside of start, update, and on particle collision, outside of all those, but within the public class, we're going to do IE numerator. I'm going to give it a name, and we're going to call this burn delay. And ignore the fact that this is underlined. This is one of the things that I don't like about Microvisual Studio. It's saying that something's wrong. Well, the only thing that's wrong is there's nothing in here yet. So it really shouldn't be doing this. It really shouldn't be giving you a warning, but it is. So what we're going to put in here, we're going to do a couple things. So yield return new, wait 4 seconds, and we'll do 0.5f. So in other words, we're going to have you take additional burn damage every half of a second. Reasonable amount of time. So, but that's arbitrary. It could be 3/4 of a second, could be 1 second, whatever. It's whatever the situation calls for. Now, as much as I like trying to explain everything, don't worry too much about this. Just know you have to type it. Really just care about this. This is what you're saying. You're saying that you're going to wait for a period of time. And again, this is independent of frame rate. So that's one of the reasons why you would use IE numerator. So you're saying wait half a second and then do something. Well, what do? We want your health to be decreased. So current HP minus equals, and say let's take out 50. Now what we're going to do is we're going to check to see if the burn time is still greater than half a second. It is, then we want this to happen again. If it's not greater than half a second, then we're just going to reset it to 0 because there will be no additional reason to come down here until another collision has occurred. So if parenthesis burn time is greater than 0.5, then we want something to happen. we want to come back here. So it becomes auto-recursive. So start coroutine, burn delay. Whoops, sorry, burn delay, not burn time, sorry. Burn delay with its parentheses. Now you're probably looking at this and say, okay, well, this will make this happen because burn delay is pointing to this. But how does this happen in the first time? So that gets to why we needed the on-fire control. So when the first collision occurs, we're going to have this bin evoked. So same thing. So start coroutine, burn delay. But we only want it to come down here once. So that's why we need the on-fire control. So if on-fire is equal to no, sorry, two equal sign, squiggly brackets, then we want on-fire to be set to yes, or y. And now this should become obvious. So this, or should I say evident, not obvious, sorry. So now what's happening is once this gets set, this will no longer be true, and it will not keep sending you back down here. It's already been sent down here, and it's auto-recursive. So you send it down here once, and it will keep doing its thing. So you don't need it to keep coming down here. You don't want it to be sent down here again until this goes back to no. So that means that has to happen down here. So if burn time is greater than 0.5, then rinse and repeat this, wait half a second, reduce HP. Else, if it's less than half a second, we're just going to wipe out the timer because the timer won't make a difference at that point. So burn time equals 0. And again, it really doesn't matter too much because this is going to keep reducing it, but just to keep it clean. So we're going to reduce burn time to 0, and on fire will then be set back to no. And so if another collision occurs here, then it will come back and it will start this again. So that's kind of a mouthful, but it's pretty straightforward, I think. I don't think I've missed anything, so let's quickly do a run through. So with every frame, burn time is being reduced, but we really don't care at first. When a collision occurs, on fire is set to yes, start the coroutine, waits half a second, reduces HP. Is there more than half a second left? Then yes, and it'll repeat this, waits half a second, and burns. But if no, there isn't greater than half a second, set burn time to 0, on fire is no, and then it comes back here. So what will happen is we will have a burn time that goes into the negatives, but we don't care because burn time will be set to 3. Actually, did we actually set burn time? We did not actually set burn time, so sorry, this part didn't quite make sense yet. That's why you read through it. So burn time with each and every collision will get reset to 3, so or 4 or whatever. I think I said 3. So that's why you read through it to make sure you aren't missing anything. So we weren't actually setting burn time to 3. Okay, so let's run it. So what should happen is we have the collisions. In addition to the 1 point of damage per collision, we also have the 50 points of damage. Oh, and actually there is one more thing. We want this to stop so as that we can see that the damage over time is indeed working. So what you can do is for the particle system, just shut off the looping because by default it's like this. Just make sure to shut it off. Actually, we're going to have to move the debug because it's going to stop displaying here. Yep. So that's an important point. The calculation is working, but since the debug is here, we need to also put this in the update section. So to the best of my knowledge, it is working. You just can't tell it's working because it wasn't displaying. And there we go. See how it stopped? And it looks like it went down about 5 or 6 times. So that should do it. So if we had the current the burn time here, you'd see it keep going to the negatives, but as you could see, it had no impact. So I think that should about do it. So about the only thing else that we could do, like I said, we are looking at only one collision per frame. You may actually care to be able to check for multiple collisions per frame. If you want to see that, I can do a follow-up video. Also, if this is on fire, we could put a separate particle system up here showing that it's on fire. So that particle system would be activated with the first collision, and then when the timer runs out, that would go off. And that's what this was here for. If I didn't mention it at the beginning of the video, I was going to use this rather than the default circle particle. So if you want to see a second video, that's what we'll do. We will make it look like a fire. We'll also look for the array, and we'll also have the fire burn at the top. So I think that's it for now. If you have any questions, just let me know, and I hope that this was helpful.